Hey, what's up? This is Doug Joseph with Design 8 Studio with a couple of quick tips for remixing in SketchUp. So I needed some DIN rail clips for a CNC plasma cutter project that I'm working on, and I found this really fantastic 3D printable DIN rail clip for just the micro step driver, the stepper motor driver that I was needing, which is a TB6600, and this one is by Klaus Diners. I hope I'm saying that right. Pretty sure I'm not, but it just had a couple of tiny things that I needed to remix. The screw holes that he has in this one are too large and not placed quite properly, and his is exactly 25 millimeters, and what I was looking for based on some other that I need to match, and also my drivers, I'm looking for just a ½ millimeter less than that. That's very minor. The screw holes are the main thing, but what I want to show you is why you can run into difficulty when you go to remix, and an easy workaround to get around that. Let's get into it. So I downloaded his file, and it brings in a step file, which is a 3D modeling file format, and this has, I think, both that stepper motor driver as a 3D model and his mount, but he also provided the STL. So one of the things that you can do is to use a conversion program to convert the step file into the format that you need. Another thing that you can do is bring the mesh in from the STL, the stereolithographic file, right into SketchUp. So if you look here, let me back out of this group and I'll show you. Here I have several iterations of earlier ones, and they're a different type of clip, and I like this kind of clip, and so I wanted to try it out in a 3D printed format. I have it positioned right on top of mine. Let me move it over by 25 millimeters, and so you can see here, I think I told you backwards. I said his screw holes were too large. It's the opposite. His screw holes were too small. So let me show you one of the problems that you can run into with this and how to fix it. So here is Klaus's model, and as is typical, many people that are modeling on some other kind of 3D modeling software will put curved edges in that are of such a fine, tiny amount of detail that it's way more than any slicer will ever need to recognize, way more than any 3D printer will ever be able to recognize, and it puts in tons and tons of geometry detail in there that can never be accessed, and it can result in lots of voids. Now here is a perfect example of what I'm talking about. Klaus's design has these tons and tons of polygons on this little tiny curve. Let me use the tape measure and show you just how small this curve is. That is about 0.11 of a millimeter. There's no way that any slicer or any 3D printer will ever pay any attention to a curve that small, and you're looking at a huge headache getting those polygons all deleted and new geometry in place to fix that. So I want to show you a neat trick. Also, you'll notice that lots of hidden lines for webbing will come through, and for every one of those ridiculously small polygons, it creates another hidden line of webbing, and SketchUp recognizes that those lines are too close together to ever matter or be needed, and it signals that by bringing them in without a face in between those lines. Now, I actually had already cleaned up quite a bit of this kind of webbing on the top of the imported model before I thought, hey, you know what, let's show folks what we're doing and why this is helpful. So as you can tell, this model has lots of holes in it. There's no way that I would be able to get this to export as a solid watertight body. And so, but there's a neat trick, and it's to clean up just one face, either on this particular type of design where simply extruding either the bottom face of it or the top face of it would work, then there's an easier fix, and that is to clean up just one, either the top or the bottom, by erasing all of these webbings and then extruding just that face and deleting all of the rest in a single go. So let me show you how to go about that. The first thing is that sometimes on really tight corners you'll find something that looks like this. There's a hole right here, and it's because SketchUp recognized that this hole was too small. And so how you can fix that is to create a face, and I'm using a face creator extension, and it's NRAW face creator, and I've assigned a hotkey to that extension, and for me on my Mac it's I think Control-Shift-F, and it automatically adds a face for me, and then you can delete the line. And so I've already done that on several places, and in some places the corner had several different lines of webbing that needed to be deleted. But I'm not working on the bottom. However, the bottom really shows you, let me go from the bottom up view. This is how the top looked when I started. This is the bottom, and I've already deleted a lot of these lines. Let me shift to the top view, and you can see the top view is now quite a bit cleaner. And so I'm just using the erase tool for my program SketchUp. The E key is the hotkey for the erase tool. And so I'm simply erasing these hidden lines that come through when you import an STL file. And I'm cleaning up one side, in this case the top, for extrusion later. I'm using the mouse pad on my MacBook Pro to zoom in and out on the model as needed. Okay, so here's another place where I have to create a face before deleting a line. Okay, so I've got one face, in this case the top face, all cleaned up, and so there's tons of bad geometry down in here that I'm going to be getting rid of. And the way that I'm going to accomplish that is by simply using the pull tool, the pull up tool, to extrude. And I will extrude up. In my case, I need 24.5 millimeters, so I'll type 24.5 in. You see that in the dialog box at the lower right hand corner of my window. I'll hit enter. It will give me the 24.5. And now what I can do is go to a front view, which for me is Command 3. And in that front view, I will simply highlight everything and hit delete. So in one whack, I got rid of all of that ridiculous geometry in this corner. Now I still have this tiny little curve, which there's no slicer, there's no 3D printer that can bother with any difference between a hard corner and a 0.11 millimeter corner. I mean, maybe, but the difference would be so minimal as to not even be worth mentioning. But at least now it's simply 1, 2, 3, 4 faces, 4 polygons, instead of the ridiculous number that was there a moment ago. And so at this point, I now have a cleaned up model that really only needs the screw holes put back in. And so I'll select all of this. Let me go, just for placing it, I'm going to group it, cut, and then paste again, lock onto my axis there, and then explode. And I'll erase the guidelines, and then I'll run the solid inspector, and it's going to, let me see, X-ray vision. Okay, it's finding one reversed face and one external face. I'll say fix all. Everything is shiny. So I now have a solid watertight model, and I can run the soften smooth edges on it and hide the invisible lines. And now I've got a really nice, wonderful airtight or watertight solid body that can be printed. So all I've got to do now is put my screw holes back into it. So I hope this has been helpful. And again, this is Doug Joseph with Design 8 Studio. If you like our content, please click like and subscribe. And until the next video, I wish you happy making.